Go ahead.
Welcome to our Rube Goldberg Transportation Around the World. We are the 3B Silver Team from Waunakee High School.
I'm Jackson.
I'm Cole.
I'm Mason.
I'm Olivia.
I'm Ada.
I'm Alex.
I'm AJ.
I'm Sydney.
Our machine travels around the world through different modes of transportation. Our main message is that through transportation, we can connect the world and create something pretty awesome, which in this case is an exploding volcano. We begin in NYC at the Statue of Liberty, where an airplane takes us to the Eiffel Tower, which lights up. We then travel to the Leaning Tower of Pisa, which does end up falling over. From there, we see the Great Pyramids and take a boat to the Golden Gate Bridge. Finally, we end up in Japan and see an erupting volcano.
Alright, our problem was to create a reaction with our homemade volcano. Our constraints were to have the machine smaller than 5 cubic feet. And we must have mechanical, chemical, hydraulic, and an electrical step. We must contain 15 to 20 steps with no more than 2 minutes of runtime. For brainstorming, we created a list of possible steps and themes, and based off this list, we made an initial sketch and theme outline. We began prototyping and creating our solution and along the way we made variations from our initial plan.
Our electrical step was the LEDs on the Eiffel Tower. The Eiffel Tower has a string of LED lights going up it. When the plane flies down the string, the plane hits the switch, and the lights on the Eiffel Tower turn on.
The lever that is just before the fluid power step is the mechanical step for our machine. The weight at one end of the lever pushes it down, which in turn pushes the other end of the lever up.
And just as Alex said, our next step is the fluid power step. And this is where we have a small syringe up here and a bigger syringe up here, and because of the difference in size, we gain mechanical advantage when this lever pushes up on this syringe, and this, which forces water through here, which pushes this other side of the syringe up. This syringe moves a further distance, but uses less force, whereas this has more force to push that over, but ends up moving a smaller distance.
So the last step of our machine includes our chemical reaction step. The baking soda in the volcano reacts with the vinegar in the cup. In the reaction, baking soda and vinegar creates water, carbon dioxide, and sodium acetate. And the CO2 gas on the product side of the reaction is what creates the erupting part of the volcano.
And lastly, the major challenge that we faced was that our fluid power step initially wasn't working the best. We didn't have enough mechanical advantage to move the second syringe up by directly placing the weight on the first syringe. So we ended up flipping the first syringe upside down and having a lever push up on the syringe and adding a second weight to the first one on the other side of the lever, and this ended up working very well.
Let's travel the world together!